In the last video, we talked about what happens or what is the trajectory of a particle when the magnetic field and the velocity are mutually perpendicular. When the magnetic field and the velocity are in mutually perpendicular direction, here the velocity is along this direction and the magnetic field is into the paper. When these two are in a mutually perpendicular, then the charged particle moves into a circular path. This is also called a trapped state, trapped. And the reason I'm calling this one as a trapped state because the charged particle will forever be trapped in the magnetic field. It will always keep moving into a circular orbit. Once it enters into a region of magnetic field, then that's it. Then forever it will keep moving into the circular path forever and ever. So this is for the circular orbit. Now, or in this case, the velocity and the magnetic field are mutually perpendicular or 90 degree. And what happens? What happens if the velocity and the magnetic field are not mutually perpendicular or are at some angle, let's say 20-degree angle or 30-degree angle, not 90 degree? What will happen? What would be the trajectory of the charged particle? So we'll be talking about this in this video. So let's say for example, this is the magnetic field direction. That means magnetic field, and here this represents the magnetic field direction. Okay, so the magnetic field is pointed towards x-axis, so that's the magnetic field direction. And the charged particle is moving along this direction, and there is some angle here, so that is the magnetic field and that's the velocity. All right, so you see it has velocity and the magnetic field are not mutually perpendicular, it is at some angle theta. Now we have to find out the trajectory of the particle. So what we can do, so this is again, here is a charged particle, it is the magnetic field direction, that's the velocity direction. So what we can simply do here is resolve this velocity into two components. So one component here I'm drawing towards the magnetic field, that is parallel to the magnetic field, and the other component is perpendicular to the magnetic field. As this angle is theta, the parallel component will be v cosine theta and the perpendicular component will be v sine theta. Now we have now two velocities, the perpendicular and the parallel component. Remember, the magnetic force will be zero, or there is no force at all if the velocity and the magnetic field are in the same direction. So due to the parallel component, there will be no magnetic force onto the charged particle, and there is magnetic force due to the perpendicular component. Okay, as there is no magnetic force acting onto the charged particle in the direction of the magnetic field, this charged particle will continue to move unaffected by the magnetic force in the direction of the magnetic field. And due to this perpendicular component, the charged particle will move into a circular path. Okay, so now as a result, the charged particle is doing two things here. It is moving in the direction of the magnetic field, and at the same time it is also moving into a circular orbit, and the result or the combination of both is it will make a helical path. Okay, so here you see the particle is moving into a circular orbit, and at the same time it is moving in the direction of the magnetic field. And again, because when the velocity is in the parallel direction, there is no magnetic force, and the magnetic force acts when it is perpendicular, and the perpendicular component will try to move it into a circular orbit, and this component will be entirely unaffected, and the result is the particle will move into a helical path or a spiral path here. And if you look at any point here, at any point, it does have the two velocities, the velocity parallel and the velocity perpendicular. The velocity parallel again will be moving along the parallel direction, and this one is in the perpendicular direction. The direction of this one is changing, but the direction of this parallel component will remain exactly the same, which is along the x-axis, and this one is changing because it is moving into a circular arc or into a circular path. All right, so here mathematically the parallel component is 0. Why is that? Because theta in this case is 0. If theta is 0, then you remember QVB sine theta. If theta is 0, then the magnetic force is 0. And perpendicular component theta is 90 degree. So this force I can write down as QVB. Here this is a perpendicular component here. All right. And you see here I have resolved this parallel component is V cosine theta, and this is a perpendicular component which is V sine theta. That's the reason I have written Q V sine theta. Okay, so the idea to learn from this lesson is when there is an angle between the velocity and the magnetic field, the charged particle will move into a spiral path. It will move into a helical path. All right. Okay, so this is it from this chapter. If you have any questions, write down your questions in the comment section below, and do not forget to like, share, and subscribe the channel. Thank you.